He just knew it as the square root of the frequency of the X-rays. Now, this was really big because before Henry Moseley, the periodic table was organized by atomic mass, which is how much the element weighs. But this was proving to not be the best way to organize the elements for lots of different reasons, reactability and different things like that. So when Henry Moseley discovered the atomic number, it was a much better way to organize elements. So Henry Moseley came up with the atomic number and kind of made sorting elements by atomic mass an outdated concept.
I'm going to draw a quick general shape of the periodic table. And the periodic table organizes all of the known elements in a way that allows us to help characterize their chemical properties by sorting them into columns and rows. So the columns are called groups, and they contain elements with the same number of electrons in their valence shell in their neutral state. And they tend to exhibit similar interactions with other given atoms or molecules. And so there are 18 total groups in the periodic table. And similarly, there are rows, which are called periods. And these are based on the total number of electron shells that an element has. So the number of the period indicates the number of shells that an electron has in its neutral state. So there are 7 periods, meaning there are 7 electron shells that an atom can have in theory. But say hydrogen, which is the first element, is in the first period, meaning it only has 1 electron shell. And because it's also in the first group, it has only 1 electron in its valence. Finally, each element has 1 more atomic number than the one that came before it. So each element in the periodic table increases the number of protons as you go from left to right.
Hello. Today, we are going to be talking about groups on the periodic table and kind of why we group different elements the way that we do. So when we're talking about the periodic table, a group is a column. You can see they're all numbered up at the top here, and there are 18 different groups in the periodic table. Now, why are the groups arranged like this? One of the main reasons is chemical reactivity. So elements in the same group are going to react the same way when exposed to similar situations. Now, what is it about the element that actually controls their chemical reactivity? That is the number of valence electrons. So all of the elements in the same group are going to have kind of the same formula for their valence electrons. So if we take a look at group 1A that I already have circled over here, the electron configuration for group 1A is NS1. So they only have 1 electron in their valence S shell. The N is just kind of representative of any number. So as you go down the group, they're going to have more and more S shells as they get bigger. But in that outermost S shell, they're only going to have 1 electron. Now, if we look at group number 2A here, they are going to have the electron configuration in their valence shell of SN2. So again, as you go down the group, they're going to have different numbers of S shells, but in that outermost S shell, they're all going to have 2 electrons. Let's look at one more example. We'll go to row 4A over here, group 4A over here. And the electron configuration for 4A is NS2, NP2. So again, those N's just depend on how big that element is. But in that outermost S and P shells for all of the elements in group 4A, they're all going to have 2 electrons in their S shell and 2 electrons in their P shell. And this is kind of why we group elements together in the way that we do, is because the same number of valence electrons means they're going to have similar chemical reactivity.
The periodic table is organized pretty nicely in a way that allows us to pretty easily distinguish the metals, the metalloids, and the nonmetals from one another based on where they're physically found on the table. So remember that the metals are generally found on the left side of the table, all the way from the first group through the transition metals plus a few more. So if we look at the elements given in the problem, we can just match up which ones are found in this metal region to determine the metals. So that's ultimately going to include iron, barium, and lithium. Then moving on to the metalloids, those are found in between the metals and the nonmetals and are really only including about 6 or 7 elements that can be found by drawing a type of staircase figure from boron through tellurium and polonium. So it's going to look a bit like this. So from the question, we can determine that the metalloids among the list are boron, silicon, and arsenic. Then finally, the nonmetals include everything on the right of the periodic table